Sup, Chem peeps? Let's keep going with strong and weak acids and bases. It says use the image below to answer the following questions. 1. Classify each of the beakers below as a strong acid or a weak acid. Easy. As I take a look at the beaker on the left and think about the key that I'm provided, notice that when I place this acid in water, it completely ionizes. Each of the acid molecules separate out into a negative ion, its conjugate base, and a proton or hydrogen ion. Complete ionization in this entire beaker, which means I would classify this acid as strong. All right, now let's take a look at the beaker on the right. When this acid is placed in water, notice that there is some ionization. There is some increase in hydrogen ions. But notice we have a bunch of the original acid molecules still in solution, indicating that this acid on the right is a weak acid. All right, let's take a look at this second question. It says determine whether the Ka value for each of the acids would be greater than, less than, or equal to 1. Well, to answer this, I'm going to write out the general equation for the ionization of an acid in water. Boom. And I'm going to write out the general expression for the acid ionization constant Ka. Boom. Remember, water is not included because it's a pure liquid. Let's go back to our strong acid and think about what is in solution. For our strong acid, we have mostly hydronium ion and conjugate base. We have virtually no original acid molecules. So Ka is going to be greater than 1. And that's true for all of our strong acids. Ka will be greater than 1. Now let's think about our weak acid. Think about what we have in solution. Sure, we do have a little bit of these hydronium ions and conjugate base ions. But in a weak acid, the vast majority of the things in solution is our original weak acid molecules. So now our denominator is going to be very large, indicating that our Ka value is going to be less than 1. And that is true for all weak acids. Ka less than 1. Done.